pOH, or sorry, pH. The pH scale, how we measure acids, people. I'm sure you've all heard of it before. Low pH means what? Strong or weak acid? Strong, or more acidic, I guess is a better way to say it. You can have a low pH with a weaker acid, but means more acidic. So it goes down to 0 all the way up to 14. The higher the number, the more basic or alkaline. So 1 molar NaOH has a pH of 14, and 1 molar HCl has a pH of 0. And then everything is in between. Okay. Neutral is 7. Okay. Logs are in this unit. Okay, you just have to know how to hit some buttons on your calculator. I will not ask you to reproduce all the log rules you learned in Chem 12 or grade 12 math. All right, but here's the definition of pH. pH is defined as the negative log of the concentration of protons, or if you don't like the protons, the hydronium ion, H3O+. That's the definition of pH. We've all done Math 12, right? Have we all done Math 12? Perfect. I'm going to assume we all know how to hit the log button on a calculator. Everything is base 10. Okay, we don't use the natural log. It's all base 10. So the LOG button on your calculator, I'm not going to go through those. If you want some help with that, I can do that for you. Calculating pH. So suppose we have a solution of a hydronium ion that is 0.025 molar. Determine the pH simply by taking blah, blah, blah. Okay. Let's just do this question. Yeah. So if you want to know what the pH is of a concentration of that, it's literally this calculation. Punch that in your calculator, you should get 1.6. Did we get 1.6? Yes? Do we all get it? Perfect. The only reason the negative is there is to make the answer positive, right? Because if you write this in scientific notation, it's 10 to the minus 2. So you get a negative number, so they show the negative there to make it positive. Okay. So 1.6. All right. Calculate the pH of a 0.01 molar sodium hydroxide solution. So, first thing you ask yourself, is this a strong base? What does that mean? Fully dissociates. So we get strong base. Therefore, the concentration of OH minus is equal to 0.01 molar, right? Because it's a 1-to-1 relationship. Okay, if I know the concentration of OH minus, to figure out the pH, I need to know the concentration of protons. How am I going to do that? Yes, the kW. So we use the kW, which is the concentration of OH minus times the concentration of H plus. kW is 1.0 times 10 to the minus 14. So if you do a bunch of math, you get the concentration of H plus is 1.0 times 10 to the minus 12. Which you could either do it on your calculator, but if it's a 1.0 times 10 to something, the answer is just whatever that exponent is, right? But if you put that in your calculator, you should get 12. pH of 12. Does that pH make sense? You should always ask yourself this. Why does it make sense? Because this is a strong base, right? It's a strong base, so we know we have to be higher pH. They should. Not like, yes, if you think about it, but they won't be as clear cut as that. But yes, theoretically, they should all make sense. No. Because what's the definition of pH? pH. There is a pOH, which we're going to do on the next page right now. Yes. Okay, are we okay? Boom. Okay, so there are pOHs. All the P means is log it. That's what it means. It's an old school way of logging. So pOH is negative log concentration of OH minus. The pKw is negative log of the KW. Okay. So it's the exact same thing. So what is the pKw? Yeah, it's going to be negative log of 1.0 times 10 to the minus 14, which is going to give me 14. All right. Now, you don't have to write anything of what I'm going to write down, okay? We're going to go mathematical here for a sec. We know the KW that's KW, right? Okay. If I negative log both sides, come on. Everybody good with that? What you do to one side, you have to do the other side. If you're multiplying the arguments, what are you doing with them in a log? You're adding them. So then we can write everybody good with that? Okay. This is pKw. What is this? What is this? What does pKw equal? So the pH and the pOH will always add to be 14. Okay? So we'll write that down. That's what you should write down. So we will go, come on, there we go. pH and pOH is equal to 14 or pKw. Okay? Actually, I'll write equals pKw and then equals 14. And this is true at 20 degrees, right? Because if you change the temperature, you change the KW. Okay? Or the KEQ. All right. So calculate the pH of a 0.01 molar NaOH solution. This is the same question we just did, but we can use our new formula. Okay? So we know that this is a strong base. Therefore, the concentration of OH minus is equal to 0.01. Well, now I can do pOH is going to be negative log of 0.01, which is 2. And since I know that the pH plus the pOH has to equal 14, the pH is going to equal 14 minus 2, which is 12, which matches the one we just did. Does that make sense? Okay, so now we don't have to do the, I'll put that back up in a sec. In this one, we had to figure out the concentration. You had to do that no matter what. But then we had to use the KW formula to calculate the H plus and then plug that into the pH. We don't have to do that anymore because we know that once we have the concentration of OH minus, I can figure out the pOH, and those always add to 14. So it doesn't matter which way you do it. It's your choice, but just another way to do it. Okay. Now, the reverse of logs, this is the most loggy part we will do in here. If I say that the pH is equal to the negative log concentration of H plus, how do I solve, going back to math 12, how do I solve for concentration of H plus? What do I do? Sorry? Sorry, got a log. We want to get rid of the log. Change to exponential form. So first of all, we'll move the negative over. I'm not going to ask you to repeat this. I'm showing you where the formulas come from. So if I move the negative over, I get negative pH is equal to log concentration of H plus. And then you change to exponential form. If you don't write the base, it's base 10. So the 10 comes over, kicks that up to become the exponent. And you get the concentration of H plus is equal to 10 to the negative pH. What's the concentration of OH minus? There you go. See? Logs are useful, people. Okay, so we have a solution that has a pH of 4.6. Calculate both H3O plus and OH minus. Okay, H3O plus is the same as H plus, thank you. So concentration of H plus is equal to 10 to the negative pH. 10 to the negative 4.6 is equal to 2.5 times 10 to the minus 5 molar. Okay, how am I going to do the concentration of OH minus? There's a couple ways you can do it. What would I do? You can find the pOH. How are we going to figure out the pOH? There you go. pOH is going to be 14 minus the pH, which gives us 9.4 is the pOH, and then 10 to the negative 9.4 is the concentration of OH minus, which is 4.0 times 10 to the minus 10 molar. There's one other way you could have done that, the old school way. Once you know the concentration of H plus is this, you could use KW. Right? And plug in 1.0 times 10 to the minus 14 and 2.5 times 10 to the minus 5 and figure out OH minus. Again, it doesn't matter to me how you do it. It's your choice. Okay? Does that make sense? For logs, all you got to do is know how to hit your button and know how to use your 10 to the power of an exponent button. That's all you'd be required in this course. I will not ask you to prove any log functions or pH equations or anything like that. Okay? You can now do all the questions in the package. There is one thing I want to show you from yesterday. Actually, I'll just do that before we get there. The last question I did yesterday, I said use moles. Remember this one? I was like, figure out the moles, and then you neutralize it, and then you add in the excess amount of moles to get it up to 0.02. And then I was driving home, and I was like, you can do it this way. This is right, but you can do it just with the concentrations. And so last night I did it with the concentrations, which is this. So we have to neutralize 0.15 molar HCl. So that means I need 0.15 molar NaOH to neutralize that, right? Because they will cancel each other out. Then I also want to bring it up to 0.02 molar NaOH. So then I add that. So I add 0.15 molar plus 0.02 molar. So I need 0.17 molar NaOH to add to this, okay? So then I'd figure out how many grams that is. That's molarity, 0.17 moles per liter, times the number of liters, times the molecular weight, gives me 1.7 grams. Is that easier? I don't know, but it's your choice. Again, two different ways to do the exact same question, okay? that's it. There's only 20 minutes of class left, so you can work on the questions or chill. Or chill. There are